Well, good morning, YouTube. I had some time this morning, so I figured I would screw around on my system and make some adjustments here. I had done a spin around on my condenser, and I'll show you that here. The service access used to be in the back corner, right under that dryer vent hood, and it was pretty difficult to get to. There was only about 8 inches of line set between the condenser and that connection. So I spun it around and put my service access on the outside, got a larger pad, extended the line set. But as you can see here, my electrical isn't very pretty. So I've got a whip ready to go in, and I was going to change that out so that my unit at my house is more worth looking at, since that's pretty ugly. So I'm going to pull out the old wire and replace that with a longer whip that'll be able to be more attractive. And I will take you along. Once we get that done, I'm going to play with the wireless pressure Zigbees and show you some of that as well. So come along for the ride. So there you have it. Got it coming down, wrapping around, and going up into the power box. And I've got crimp connectors here to hold the stranded wire with the loop on the end. They had Romex in there before, and this is what I used to go back, crimp it down real good, and even got one down there on the ground. So she's wired up, and we're going to talk about wireless pressure probes. Alright, so we are in the iManifold app. We are already connected. As you can see, we've got liquid line, outdoor, and delta or discharge. Going to go into wireless probes. You can see me in the camera there. We are going to add, and we're going to start with the temperature probe that we want to use for supply. We are looking for probes. We're going to press and release the wireless button until we get a notification telling us that we are connected. We have success. We do want to add another probe. We're going to move on to the return probe. We have success. We do want to add another probe. Going to move on to the high pressure probe. We have success. We do want to add another probe. Going to move on to the suction probe. We have success. We do want to add another one. Going to move on to the repeater. We have success. And we are done. So now you see we have probe 1 as temperature and humidity, probe 2 as temperature and humidity, probe 3 as high pressure, probe 4 as low pressure, and probe 5 as a repeater and temperature. There you go. We've got high pressure tied into the high pressure connector, and we've got T1 tied to a strap clamp on the liquid line, and we've got low pressure tied to the suction line, and T1 tied to the suction line. Probe 1 is temperature and humidity. Probe 2 is supply air temperature and humidity. We are going to map this one since it's not mapped. Return air. It's that easy, guys, to map them. Probe 3, we've got high pressure and liquid line temperature. Probe 4, we've got low pressure and suction line temperature, as well as superheat. And the repeater probe displays no information because nothing is connected to T1 and T2. Now, if we go back to the manifold, I wanted to point this out because it threw me for a loop for a second. If we go over to probe 5, there's probe 1, probe 2, probe 3, probe 4, and this is what probe 5 looks like. If I were to connect a strap lead to this probe, it would then show that information. I'm going to go ahead and tie into T1. And you see T1. Going to switch it out for T2. T1 drops away. T2. And that clicking noise that you might have been able to hear was the probe being inserted, and about 1.5 seconds later the data pops up. So they respond very quickly. There you go. So just for fun, we're going to leave this probe in the repeater so that we can confirm connectivity. And we're going to go ahead and put the temperature probes in the ducting in my attic. The return air probe is into the return plenum on this side of the unit. And the supply air probe is over here in this distribution box. And then we're going to take the repeater probe and, just for fun, show it over by one of the supply registers on the second floor. There you have it. The magnets on the repeater probe allow me to stick it to the register. And then we've got that ambient air sensor plugged into the T1 port, and it ought to get some air coming off of the register. Trying to get it to where it makes sense in the airstream. Let's do it this way. Since these louvers deflect air, that direction will get it so that probe hangs out in front of that set of louvers on the register. So we've got our repeater probe showing ambient around that register. LP is low pressure. HP is high pressure. Supply air, dry bulb, and return air, dry bulb. System is not running. If we come up here and touch the little Wi-Fi icon and switch from iManifold to wireless 4, we see our suction pressure, saturation, and superheat. Come over here to the high pressure Wi-Fi icon, switch to wireless 3, we see our high side pressure, saturation, and no subcooling as the system is not running. Before we turn the system on, we're going to go over here to trending. Going to set up trends. For fun, we're going to do the pressure low, pressure high, and set this up for every 2 seconds. And we're going to show 90 points of data on the screen. And we're going to submit that. So there we are showing our trends. We're going to go ahead and go over to the profile, and I have saved my system over here. We've got a piston orifice, and so no target subcooling, and actually I don't have an outdoor ambient. Let me see if I can fix that. So the outdoor ambient is not going to be totally accurate because it is off of the iManifold sitting on my dining room table right now, but at least it'll give us that information based off of ambient in my first floor dining room table. So we've got profiling, and we're going to go back to trending, and then we're going to go over to the Nest website. Going to take my living room thermostat and drop that down. System started up already. Since I am zoned, I'm going to set the upstairs down as well and jump over to the trending again. So there we got both zones calling. Jump back over to trending, and you can see how the trending tracks with 90 points displayed. It's tracking over a very decent time. Now, if I wanted to, I could go into options and retrend rather than every 2 seconds, every 4 seconds, and that will extend the 90 points to show even more time. It just won't show as regularly. It'll show every 4 seconds instead of every 2. So there we are with that. We're going to go back to the manifold display and watch how the system changes as it runs. Just for fun, it looks like I've got my supply and return backwards. So we're going to go back over to the wireless probes. We're going to take the probe 1, which is set up as return at this point, but obviously wrong. And we are going to remap as return air, and then remap this as supply air. So now we should see that information properly. And there we go. So we can see that we've got pressure, running pressure. I'm going to go back to trends to show that information. And you can see we came up, waved down a little bit, and we're coming back up into the blue line for ambient and outdoor temperature, which is actually the temperature in my living room. We're going to go back over to wireless probes and look at that information. Since we did have it set up in the airstream off of that register, we are getting a temperature off of that. And just for fun, you can see that I'm apparently losing about 4 degrees of delta T from the distribution box for the second floor over to the register air output itself. So not necessarily something that is a specific tool, but it shows you how you could prove whether you're losing temperature across the ducting or whatever. You could prove that the insulation value is not exactly that great. Now, it may adjust over time. So it looks like the delta T between the distribution box and the register is getting a little bit closer. Just so that we cover as much information as possible, we're going to go ahead and go over to system performance. You can see that my pressures are within the allowable range. Superheat is probably off, and let's actually go look at that for a second here. We're going to look at target superheat. My pressure is pretty close, but my superheat is obviously off by about 9 degrees. And there you have it. Currently, under the coil performance that I'm getting, I've got a standard CFM of 424 per ton and 1271 overall. My target temperature split is short by 1 degree. My calculated tonnage is 3.3. I've got 39,000 BTUs total, with 20,000 allocated to sensible and almost 19,000 allocated to latent, with a sensible heat ratio of 0.52, and I've got a bypass factor on my coil of 0.61. Dew point entering is 61.4 and dew point exiting is 52.9. We have evened out on the trending, and you see a little bit of fluctuation on the high pressure side, but well within the pressure range. Suction pressure is running a little bit low, but if I had my superheat right on the money, that would be expected to fall within the middle of that pressure range. 28 rather than 20. Not too bad though for a 13-year-old York trash can. Go back to system performance, see how that has changed. Not a whole lot. My target temperature split has gone up a little bit to almost 16. Still lagging behind by about 1 degree roughly. But the CFM has maintained its accuracy to the true 1200 nominal. Pretty decent, I'd say. Like I said, 13 years old. I did add some refrigerant a while ago on one of the other videos, and I don't see the sense in leak searching my own system when I'm more than likely going to replace it fairly soon, rather than add refrigerant every year or bother with a leak search. Obviously, for me, an evaporator coil wouldn't be terribly expensive, but it's just not worth it. I mean, we all should understand that efficiency improvements since 13 years ago are well worth the investment. Even if we're not making it, we understand it and would like to. We're just not all in a position to actually afford it. So anyway, so we've got the system running, and we're going to go ahead and pull the hoses off while it's got high pressure on the high side, just so you can see what kind of release we've got. Not too bad, I don't think. No worse than the 6-inch long ball valve hose connectors. Low side should be even better than that. Basically nothing on that side. So I'd say we're good to go. Release the Krakens. those are the wireless pressure probes, and my system's not doing too bad. Thanks for watching, guys. Like, subscribe, comment, and share, and we'll see you on the next video.